Hello everyone. Today, let's learn how to evaluate the fineness of the sand for construction. As you can see, this is a sand manufacturer that can produce many kinds of sand with different particle sizes, such as coarse sand, medium sand, fine sand, and ultra-fine sand. So, with so many different types of sand, when we mix concrete in engineering practice, which one should we choose to use, coarse sand or fine sand? For the same amount of sand, the total specific surface area of fine sand is larger than that of coarse sand. In concrete, the surface of sand needs to be wrapped with cement slurry. The larger the total specific area of sand, the more cement slurry needed is to wrap the surface of sand. On the premise of meeting the strength, when the requirement of concrete mixture workability is certain, it is obvious that coarser sand should be used. The amount of cement slurry required by finer sand is more economical. The less the amount of cement slurry is, the lower the cost of concrete will be. However, if the selected sand is too coarse, the water retention of concrete mixture will decrease, and segregation, bleeding, and other phenomena will occur in serious cases, resulting in quality defects such as honeycombs, pitted surfaces, cavities, exposed reinforcing bars, and cracks in hardened concrete. Therefore, the sand used for making concrete should not be too fine or too coarse. Generally, medium sand should be selected as far as possible for concrete and engineering. So, how do we judge whether the sand is coarse, medium, or fine? In engineering practice, we introduce a new concept, fineness modulus, to accurately measure the fineness of sand. How to determine the fineness modulus of sand? Next, the focus is on how to determine the fineness modulus of the sand for construction through sieve analysis, as to evaluate the sand's fineness. Test environment. The temperature of the laboratory shall be kept at 20 plus or minus 5 degrees Celsius. And the instruments and equipment required for the test include the air drying oven with the temperature controlled at 105 plus or minus 5 degrees Celsius, the balance with a capacity of 1,000 grams and a sensitivity of 1 gram, square hole sieve, one sieve of 0.15 millimeters, 0.30 millimeters, 0.60 millimeters, 1.18 millimeters, 2.36 millimeters, 4.75 millimeters, and 9.50 millimeters, with sieve bottom and cover, sieve shaker, enamel tray, brush, spoon, scraper, etc. Test steps. They can be summarized as taking, drying, weighing, sieving, and calculating. 1. Taking. Take samples according to the standard sampling method, with reference to the quantity specified in national standards. Screen out particles larger than 9.50 millimeters. Calculate the percentage of screen residue, and divide the sample into about 1,100 grams by quartering. 2. Drying. Put the divided sample into a tray. Place it in an air-drying oven at 105 plus or minus 5 degrees Celsius to dry to constant weight. Take it out and put it in a sealed container. After cooling to room temperature, divide it into 2 roughly equal parts for later use. 3. Weighing. Accurately weigh 500 grams, accurate to 1 gram, of dried sample, and place it on the uppermost square hole sieve with a nominal diameter of 4.75 millimeters, which is arranged according to the size sequence of sieve holes and with large holes above and small holes below. After covering the sieve cover, install the sieve set into the sieve shaker and fasten it tightly. Start the sieve shaker for 10 minutes sieving. And then take out the sieve. 4. Sieving. After taking out the sieve set, manually screen one by one in a clean tray, from large to small mesh size, until the number of samples screened per minute does not exceed 0.1% of the total amount of samples. The sample that passes through the sieve shall be combined into the next sieve and manually sieved together with the sample in the next sieve. The process continues in this order until all the sand is sieved. Weigh the screen residue on each sieve, accurate to 1 gram, and record the test data. 5. Calculating. Calculating and evaluating results. Calculate the percentage retained, the screen residue on each sieve divided by the total mass of the sample, accurate to 0.1%, and the accumulated retained percentage on each sieve, the sum of the percentage retained and the percentage retained with meshes greater than the sieve, accurate to 0.1%. The fineness modulus shall be calculated according to the following formula, accurate to 0.01. Note: 1. The accumulated retained percentage is the average value of 2 test results, rounded to 1%. 2. The fineness modulus shall be the arithmetic mean value of 2 test results, accurate to 0.1. When the difference between the fineness modules obtained from the 2 tests is greater than 0.20, resampling shall be carried out for testing. 3. After the screening test, if the difference between the sum of screen residue on each sieve and the residue in the bottom plate of all sieves and the total mass of the sample before screening exceeds 1%, resampling shall be carried out for testing. Exercises to consolidate knowledge. Next, let's look at a group of test data records of fineness modulus of sand for construction after the sieve analysis test. For square hole sieves with mesh sizes of 4.75 millimeters, 2.36 millimeters, 1.18 millimeters, 0.60 millimeters, 0.30 millimeters, and 0.15 millimeters respectively, the screen residue mass is 10 grams, 83 grams, 106 grams, 144 grams, 95 grams, and 58 grams in turn, and the mass on the sieve bottom is 4 grams. Divide the screen residue on each sieve by the percentage of 500 gram total sample mass, accurate to 0.1%. Obtain the percentage retained AI, which is 2.0%, 16.6%, 21.2%, 28.8%, 19.0%, and 11.6% respectively, and plus the percentage retained on sieves with meshes greater than the sieve, to obtain the accumulated retained AI percentage on each sieve, which is 2.0%, 18.6%, 39.8%, 68.6%, 87.6%, and 99.2% respectively. Substitute the accumulated retained residue AI of each sieve into the calculation formula Mx equals A2 plus A3 plus A4 plus A5 plus A6 minus 5 A1 divided by 100 minus A1, and then the fineness modulus Mx equals 3.1 can be obtained. According to GBT 14684-2011 standard, it can be judged that the sand for construction is coarse. Okay, let's review what we learned in this lesson. By learning the concept of fineness modulus, as well as the test process and calculation method, we understand how to accurately judge the fineness of the sand for construction. The test steps of fineness modulus can be summarized as taking, drying, weighing, sieving, and calculating. Have you now got it?